This question we got f of x is x squared minus 2 quadratic, and then we got square root function for g of x, square root of x plus 4. So we're going to sketch them. Always a good idea to sketch them. Think about the domain and range of both functions, and then we'll show you how to get, the range is the hardest thing, so let's look at, so first of all, let's just work out the rule for it. So we've got h of x is g of f of x. So we know that g of x is square root of x plus 4. So g of f of x is going to be g of x squared minus 2. So we're replacing the x with x squared minus 2. So x squared minus 2 and then plus 4. And obviously to simplify that, it's going to be the square root of x squared plus 2. So h of x is going to be that function. So now we want to look at more detail what the domain and the range is going to be. Now, if it does exist, which it is going to exist, then the domain of g of f of x is going to be the inside. So it's going to be the domain of f of x. But we'll just show you how that works. So we'll start off with x here. And then the first function that we perform on x is going to be f of x. Second function we're going to perform is going to be g. So it's going to be, that will give you g of f of x. So first function f followed by g. So when we do that, we start off with, so just think about the first part of the function. You're starting off with the domain of f. And when you put in the domain of f, you get out the range of f. The second part of the composite function is the function g. So we're starting off with the domain of g. And then we're going to get out the range of the composite function. This is going to be the key to whether it exists and what the range is going to be. Okay, so if we look at drawing both of these graphs, then we can look at what the domain and the range is for both of them. So we'll do the quadratic f of x first. We get x squared minus 2. Just moved it down 2, so it's going to look like this. Not great, but something like that. Okay, and then drawing the square root function, we've got square root of x plus 4, so this is a translation of 4 units to the left. No reflections or anything, so it's going to look like this. So that'll be minus 4. So using our graphs here, we can do a domain and range table. Let's think about the domain and the range of both of these functions. So starting off with, this function is f, and this one being g. So our domain for f is going to be r, and our range is going to be negative 2 including up to infinity. If you see your y values there. G, domain is going to be starting at minus 4 and going to infinity. The range is going to be 0 to infinity, and that will be including. So now we can fill this in. So we'll see the domain of f here is going to be just r. The range of f is going to be minus 2 to infinity. The domain of g is going to be minus 4 to infinity. So this is the interesting part to see whether it exists or not. So what we're getting out here, you see, from the first part of the composite function, is you're getting answers from minus 2 to infinity. Now the second part of the composite function, g, only works for values between minus 4 and infinity. So are there any values that you're getting out here that are not going to fit in here? And the answer is no. Everything's going to lie within, so it's going to be what we say a subset. So that means that it's going to exist because the range of f is a subset of the domain of g. All these values that we're getting here from minus 2 to infinity are going to fit here. There's no values there that are going to stop the second part, g, of the composite function working. So therefore it exists. So if it exists, then the domain of h of x, the composite function, is just going to be equal to the domain of f. So again, the way you can remember that is, if it's g of f of x, then the domain will be the inside function, which in this case is f of x. But you can see that from the sketch here that it's going to start with the domain of f, the whole composite function. So if we think about getting the range now, okay, I'll just take these away. Think about taking the range, then what's going to happen is, although it does exist, the domain of g is now going to change, okay, because we're only getting out values from -2 to infinity in the part f of the composite function. So therefore, this will no longer be your domain of g. Your domain of g will be purely between -2 and infinity. So if we look at the second part here, g, what we want to do is just think about the graph and think about what the graph exists, but only now between -2 and infinity. So if we go to -2 here, you see, then this is what's going to give us a range. It's just going to exist for this part. The domain's going to be slightly restricted now. So you're going to lose like -4, -3 because you're not getting those answers out in the first part. So therefore, they are not going to be included in the second part of your composite function. So here, this value is going to be -2. And then if I sub -2 into g, which g is there, so it's going to be -2 plus 4. So that's going to be √2. So now we can use this to find out what the range of the composite function is going to be. So that means that the range of h of x is just going to be this part here. So it's going to be from √2 and going up to infinity. Then we can look at this on CAS now to see if we got it right. So f of x is x squared minus 2. Let's just define that. So x squared 2, and then g of x is the square root function, which was square root of x plus 4. Alright, so now I can define h of x. So h of x is going to be, it was g of f of x. So just type it in. So if you want what the actual function is to check it, you can just press h of x equals. That's what we've got. You can go into the book here, look for your domain, and just type it. So the domain of h of x, you need to say variable, comma x, was r again, which is what we got. And then to get the range, you really have to sketch it. So let's sketch this function, see what it looks like. So h of x here looks like this. You'll see here, this is so this is going to be √2, what we got. So what you can do here is just go, probably easiest just to do f min. You could differentiate it, you know, but f min of the function here is going to be 0. And then subbing that 0 in should give me √2. So that's why it's √2 to infinity. So that's all good.